Hello friends, in my previous video I have already discussed about how to simulate analog, passive, band pass, low pass, high pass filters. Remaining is band stop filter. So let us try to simulate band stop filter in our this video. Already in my previous video, that is example 11, you can check in the passive filter playlist, the 13th video, you can check there. I have discussed one example of band stop filter. Okay, see here, quite easy circuit, resistor and capacitor inductor series combination. If we take output across the resistor, then that is nothing but band pass filter. If you take output across this capacitor inductor series combination, then this circuit will behave like a band stop filter. Okay, and I have derived in theoretical manner why this is band stop filter. But now let us try to observe the simulation in Matlab and let us check whether it is matching with our theory discussion or not. So let us see what was the transfer function we got after simplification. See here, we have got h of omega, that is v output of j omega by v input of j omega, as 1 plus j square omega square LC by j omega RC plus j square omega square LC plus 1. Okay, so this is our transfer function. Now from this transfer function we should plot the magnitude, or you can say, yeah, magnitude of the transfer function for various values of omega, and we can check what type of transfer function we are getting. From there we can conclude that what type of filter is that. So for that, first see, omega is not known to us, L is not known to us, capacitor value is not known to us, resistor value is not also known to us. So what we will do, we will just first assume resistor, inductor, capacitor value. If it is given in the question, well and good, you just substitute that. But as it is not given for our case, so we will assume L as 1 Henry, capacitance as 1 Farad, resistance as 1 ohm. And see, by simplification, we will get h of omega as 1 plus j square omega square by j omega plus j square omega square plus 1. Now if you substitute j square as minus 1, because we know from the concept of complex number that j or I is nothing but root over of minus 1. So basically j square is nothing but minus 1, or I square is nothing but minus 1, whatever you say. So basically after putting that j square equal to minus 1 in this expression, we will get h of omega as 1 minus omega square by j omega minus omega square j omega minus omega square plus 1. Now let us try to plot that in the Matlab. So omega, I am keeping the range from 0 to 500 with very small increment 0 to 0.01. Okay, why I am keeping very small increment? Because you know that in the plotting, obviously you want to plot continuous domain, so small increment we should give. Now write the transfer function as it is, 1 minus omega square dot by 1 minus omega dot to the power 2 plus j omega. Okay, j star omega. See, don't forget this type of points, because it may arise as error if you don't forget to give this dot by. Why dot by? Because the numerator is a sequence or array or vector, you can say, and the denominator is also another vector. So obviously vector by vector, if you want to do element by element division, then obviously we should give dot by. Same goes for here, omega is an array or vector, so dot power for that. Why? Because so that it will perform element by element power. Okay, now just press Ctrl A, right click, evaluate selection. Okay, see what type of filter we are getting. Observe this filter carefully, because here is the concept of visualization, so that you can clearly remember this concept forever. Okay, or otherwise you can say at least up to exam, at least you can remember. Okay, so no one can remember one concept for longer time if you do not revise it anyway. So see, for low frequency, observe the graph carefully. This is obviously semilogx graph we are plotting. Here the x-axis is variation of frequency, y-axis is gain, or basically magnitude of the transfer function. Okay, now see, for very low frequencies the gain is basically 1. For very high frequencies also gain is 1. For a middle frequency, here 10 to the power 0 or f is equal to 1 or omega equal to 1, we can say, because f is equal to 1 by because f and omega relation is omega equal to 2 pi f. So instead of saying as f, we should say as omega, because we are plotting with respect to omega, right? So see, at this 10 to the power 0, when omega equal to 1 rad per second, see, this particular frequency range it is not allowing, okay, or it is rejecting this particular frequency band, and for all other frequency band it is allowing, okay. So this is nothing but what? Band stop filter, because it is stopping a particular frequency range, okay. So this is all about realization of band stop filter, analog passive band stop filter in Matlab. Okay, this is the fold simple line course with which you can visualize the band stop filter in Matlab. This is all for my this video. I will post this code in the description of my this video. You can check from there, and the corresponding theory video also I will give the link separately. Okay, thank you for watching.